Today we're going to be talking about Layer 1 devices, Layer 2 devices, and then we're going to conclude with Layer 3 devices. There's a fair amount of information to cover, so let's go ahead and dive into this session. Of course, I'm going to begin with Layer 1 devices. Well, before I start talking about the Layer 1 devices, we need to talk about the Open System Interconnection model, the OSI model. It was developed as a way to help disparate computing systems to communicate with each other. The OSI reference model has 7 layers. Layer 1 is the physical layer, Layer 2 is data link, Layer 3 is network, Layer 4 is transport, Layer 5 is session, Layer 6 is presentation, and Layer 7 is application. We're going to be discussing the bottom 3 layers, layers 1, 2, and 3 today. Now, most devices do function at more than one layer of the OSI reference model. But when it comes time to determining where they fit into the model, you must first determine the highest level at which they operate, because that's where they fit into the OSI model. To do that, you must know what they do and how that relates to the OSI model. And with that, let's talk about analog modems. The word modem is actually derived from a contraction of modulator, demodulator. Modems were developed to take a digital signal coming from a digital node and convert it to an analog signal, modulating the signal, and placing it on a wire. In return, it would accept an analog signal from the wire and convert it, demodulating the signal, back to a digital signal that the node can understand. Modems were developed to create a connection between network segments via the public switched telephone network using the plain old telephone system. Now, modems provide for a single connection to a network, and they're only concerned about the wire. And the wire resides on the physical layer, Layer 1 of the OSI model. It doesn't care where the signal comes from, it just does its job. Then there's the hub. A hub functions as a concentrator or repeater in that it doesn't care where the signal comes from or where the signal is going, kind of like the modem. It takes an electrical signal that arrives on a port and replicates that signal out all of its other ports. A hub may have just a few ports or it may have many ports. And for a variety of reasons, the hub is not very common anymore in the modern network. So now let's move on to Layer 2 devices. The first Layer 2 device that we're going to talk about is the switch. A switch utilizes an application-specific integrated circuit chip, an ASIC chip. The ASIC chip has specific programming that allows the switch to learn when a device is on the network and which ports it is connected to via that device's Layer 2 MAC address. That's what makes a switch a Layer 2 device. A switch may have just a few ports or it may have many ports, kind of like the hub. And although a switch is smarter than a hub, it can still be very simple or it can be highly complex and programmable. A switch can only communicate with local network devices. Another Layer 2 device that we need to talk about are wireless access points, the WAP. A WAP is a specific type of network bridge that connects or bridges wireless network segments with wired network segments. The most common type of WAP bridges an 802.11 wireless network segment with an 802.3 Ethernet network segment. Just like a switch, a wireless access point will only communicate with local network devices. Now let's move on to Layer 3 devices. And first up is the multi-layer switch. A multi-layer switch provides normal Layer 2 network switching services, but it will also provide Layer 3 or higher OSI model services. The most common multi-layer switch is a layer 3 switch. It not only utilizes an ASIC chip for switching, but that ASIC chip is also programmed to handle routing functions. This allows the device to communicate and pass data to non-local network devices. A multi-layer switch is a highly programmable and complex network device. A multi-layer switch may have just a few ports, or it may have a lot of ports. They're not very common in the small office, home office network because they're really, really expensive. You're more likely to find them in an enterprise local area network. Now let's move on to the router. A router is the most common network device for connecting different networks together utilizing the OSI model's layer 3 logical network information. That's what makes a router a layer 3 device. The router uses software programming for decision making as compared to the switch's use of an ASIC chip. The router uses this programming to keep track of different networks and what it considers to be the best possible route to reach those networks. A router can communicate with both local and non-local network devices. In most cases, a router will have fewer ports than a switch. Now that concludes this session on the Introduction to Network Devices Part 1. We talked about Layer 1 devices, we talked about Layer 2 devices, and we concluded with a couple of Layer 3 devices. Today we're going to discuss some security network devices, and then we'll move on to some optimization and performance devices. And with that, let's go ahead and begin this session. And we will begin by talking about security devices. First up is the firewall. Now, a firewall can be placed on routers or hosts in that it can be software-based, or it can be its own device. A firewall functions at multiple layers of the OSI model, specifically at layers 2, 3, 4, and 7. A firewall can block packets from entering or leaving the network, and it does this through one of two methods. It can do it through stateless inspection, in which the firewall will examine every packet that enters or leaves the networks against a set of rules. Once the packet matches a rule, the rule is enforced and the specified action is taken. Or it may use stateful inspection. This is when a firewall will only examine the state of a connection between networks. Specifically, when a connection is made from an internal network to an external network, the firewall will not examine any packets returning from the external connection. It only cares about the state of the connection. As a general rule, external connections are not allowed to be initiated with the internal network. Now, firewalls are the first line of defense in protecting the internal network from outside threats. You can consider the firewall to be the police force of the network. Then there is the Intrusion Detection System, the IDS. An IDS is a passive system designed to identify when a network breach or attack against the network is occurring. They're usually designed to inform a network administrator when a breach or attack has occurred, and it does this through log files, text messages, and/or through email notifications. An IDS cannot prevent or stop a breach or attack on its own. The IDS receives a copy of all traffic and evaluates it against a set of standards. The standards that it used may be signature-based. This is when it evaluates network traffic for known malware or attack signatures. Or the standard may be anomaly-based. This is where it evaluates network traffic for suspicious changes. Or it may be policy-based. This is where it evaluates network traffic against a specific declared security policy. An IDS may be deployed at the host level. When it's deployed at the host level, it's called a host-based intrusion detection system, or HIDS. More potent than the intrusion detection system is the intrusion prevention system, the IPS. An IPS is an active system designed to stop a breach or attack from succeeding in damaging the network. They're usually designed to perform an action or set of actions to stop the malicious activity. They will also inform a network administrator through the use of log files, SMS, text messaging, and or through email notification. For an IPS to work, all traffic on the network segment needs to flow through the IPS as it enters and leaves the network segment. Like the IDS, all of the traffic is evaluated against a set of standards, and they're the same standards that are used on the IDS. The best placement on the network segment is between a router, with a firewall hopefully, and the destination network segment. That way all the traffic flows through the IPS. IPSs are programmed to make an active response to the situation. They can block the offending IP address, they can close down vulnerable interfaces, they can terminate network sessions, they can redirect the attack, plus there are more actions that an IPS can take. The main thing is that they are designed to be active, to stop the breach or attack from succeeding in damaging your network. Let's move on to the Virtual Private Network Concentrator, the VPN concentrator. Now this will allow for many secure VPN connections to a network. The concentrator will provide proper tunneling and encryption depending upon the type of VPN connection that is allowed to the network. Most concentrators can function at multiple layers of the OSI model. Specifically, they can operate at layer 2, layer 3, and layer 7. Now, outside of internet transactions, which use an SSL VPN connection at layer 7, most concentrators will function at the network layer, or layer 3 of the OSI model, providing IPsec encryption through a secure tunnel. Now let's talk about optimization and performance devices. We will begin by talking about the load balancer. A load balancer may also be called a content switch or content filter. It's a network appliance that is used to load balance between multiple hosts that contain the same data. This spreads out the workload for greater efficiency. They're commonly used to distribute the requests or workload to a server farm among the various servers in the farm, helping to ensure that no single server gets overloaded with work requests. Then there's the proxy server. A proxy server is an appliance that requests resources on behalf of a client machine. It's often used to retrieve resources from outside untrusted networks on behalf of the requesting client. It hides and protects that requesting client from the outside untrusted network. It can also be utilized to filter allowed content back into the trusted network. It can also increase network performance by caching or saving commonly requested web pages. Now that concludes this session on the Introduction to Network Devices Part 2. We talked about some security devices that you may find on your network, and we concluded with optimization and performance devices that may also be present.